Okay, sir.
गुड इवनिंग। चलो, सो केटीजी में बेसिकली आपको मालूम है, केटीजी में काइनेटिक थ्योरी ऑफ गैसेस में क्या करने वाले टेल में। काइनेटिक थ्योरी ऑफ गैसेस में kinetic theory always they assume that the gas molecules are made up of gas is made up of small molecules, and based on that they explained everything, like all the laws they explained kinetic theory. Okay, so kinetic theory में basic assumption क्या है, all gases are made up of molecules, and molecules का vibration की वजह से only pressure, volume, everything is changing. Okay, so first we learn about the gas laws in the things. देखो gas laws. So gas law में क्या क्या है? फर्स्ट वन इज बॉयल्स लॉ। बॉयल्स लॉ मालूम है ना? व्हाट इज बॉयल्स लॉ? चलो, कुछ याद है
Sir,
बॉयल्स लॉ?
P1 V1 equal to P2 V2.
दैट मीन्स एट कांस्टेंट व्हाट? कांस्टेंट टेम्परेचर,
Pressure.
राइट? देखो, एट कांस्टेंट टेम्परेचर द प्रेशर ऑफ ए गिवन मास ऑफ गैस इज इनवर्सली प्रोपोर्शनल टू वॉल्यूम. ओके, so P is inversely proportional to volume at constant temperature. This is Boyle's law. And when I remove, I multiply किया तो क्या होगा? PV equal to constant. This is Boyle's law. On the video. एंड कांस्टेंट टेम्परेचर मीन्स नथिंग बट उसका नाम क्या होगा? आइसोथर्मल बोलते हैं. आइसोथर्मल. आइसो मीन्स सेम, थर्मल मीन्स हीट, राइट? तो आइसोथर्मल मीन्स टेम्परेचर आल्सो कांस्टेंट. लिख लो. Okay, so mathematically we can say if the gas changes from state 1 to state 2, P1 V1 is equal to P2 V2. The numerical में we can use P1 V1 equal to P2 V2. So इसका ग्राफ्स कैसे रहेगा? कब बेटा? हाँ, डेरिवेशन वी कैन डिराइव फ्रॉम द आइडियल गैस इक्वेशन. फेमस इक्वेशन आपको मालूम है ना? PV इक्वल nRT. डेरिवेशन लिखने की जरूरत नहीं है, बट अंडरस्टैंड. सो PV इक्वल nRT. PV इक्वल nRT इज द बेसिक आइडियल गैस इक्वेशन, राइट? उसमें टेम्परेचर कांस्टेंट है. टेम्परेचर कांस्टेंट है तो NR आल्सो कांस्टेंट. That means PV equal constant. This only Boyle's law, right? From ideal gas equation से all laws can be derived from it. चलो, P1 V1 equal P2. Derivation लिखने की जरूरत नहीं है. Next.
So one second. क्या सर डन?
Yeah. So इसका ग्राफ कैसा रहेगा? P is inverse proportional to V, right? So rectangular hyperbola ऐसा रहेगा ऐसा. As the volume increases, the pressure decreases at constant temperature में. Okay, this is मान लो T1 temperature. अगर मैं टेम्परेचर बढ़ा है तो that to constant लगा रहूंगा. Suppose this is at 50 Kelvin. Suppose 70 Kelvin में if I draw the pressure and volume में, the graph will be shifted like this. T2. Here T2 is greater than T1. Okay. Now इसका slope if we can find, slope क्या आएगा? Change in y by change in x, right? So dp by dv is nothing but minus p by v. Negative है slope because if I draw a tangent it is greater than 90. Greater than 90 वाला negative है ना? So minus p by v is the slope of the PV graph. डन। चलो, नाउ रियल गैस एंड आइडियल गैस का ग्राफ ड्रॉ करेंगे। सो पीवी ग्राफ का वी गेट रेक्टेंगुलर हाइपरबोला, राइट। सो अगर आइडियल गैस लिया, आइडियल गैस बोले तो we have done some certain assumptions everything, the gas का ग्राफ will be ऐसा आता था, ओके। मान लो टेम्परेचर T1 में, बट रियल गैस लिया, रियल गैस मीन्स जो हम लोग लैब में जो एक्सपेरिमेंट लेके किया ना, दैट गैस का इफ आई ड्रॉ एट कांस्टेंट टेम्परेचर, इफ आई ड्रॉ द ग्राफ, इट इज कमिंग लाइक दिस इज टेम्परेचर T1, ओके। नाउ टेम्परेचर को बढ़ाया, टेम्परेचर को बढ़ाया T2, T2 में द आइडियल गैस इक्वेशन विल बी लाइक दिस T2 and real gas if I draw is coming like this. That means at high temperature में the real gas will behave like ideal gas. Very important. At high temperature में real gas will behave like, because it is, देखो ये दूर है, इसमें क्या होगा, T2 is greater than T1, right? When the temperature is increasing, the real gas and ideal gas are coming closer. That means at a high temperature, the real gas will behave like ideal gas. Okay, and low pressure also आगे आएगा आपको, low pressure also, low pressure will ask bits में क्या होगा, at low pressure and high temperature में the real gas will behave like a ideal gas.
So is there low pressure?
Low pressure, high temperature and low pressure आगे आएगा, how the graph. But if you see at high temperature में the real gas and ideal gas, or ideal gas and real gas are almost matching. So this solid one is ideal gas and this is real gas. Okay. Now, can you explain in terms of why this is happening? The pressure is inversely proportional to volume at constant temperature. In terms of kinetic theory का help लेके बोलो, एक container है, gas molecules are there. You explain in terms of kinetic theory, how they explain? Because at that oldness में they don't know why this is happening. Inverse relation हो रहा है, but कैसा बोले तो kinetic theory came into picture. They explain everything, each and every law they explain. How, tell me, molecules के terms में बोलो. My temperature constant. What is temperature means? I told you the average kinetic energy of the molecules, right? May average kinetic energy of the molecules are same. Why? Because temperature is same, right? Now in this may, if I decrease the volume, piston से container में, what will happen? The pressure क्या होगा? If I decrease the volume, the heating वाला will increase, right? The heating molecules will increase or not? समझ में आ रहा है? This is a container. This is a piston. Okay, this is the molecules are there. Okay, I am putting temperature constant. मतलब average kinetic energy of the molecules will be same, right? Average kinetic energy of the molecules will be same. Okay, now क्या करूँगा? मैं volume को decrease करूँगा. piston को move करूँगा नीचे move किया तो when I came up to here, what will happen? Volume को decrease किया. Then pressure क्या होगा? That heating will increase more, right? Container को ज़्यादा heat करेगा. That's why pressure is increasing. So this is what explained by the kinetic theory. Okay. So kinetic theory explained the average kinetic energy of the molecules is constant. Why? Temperature is constant. If you decrease the volume, molecule hits the wall more frequently and pressure increases. So this is what explained. No need of writing, but understand. The kinetic theory explained this one. If you increase the volume, क्या होगा? Fewer collisions होगा, pressure decreases. So olden days में they don't know why it is increasing, why it is decreasing. After kinetic theory, they assume certain assumptions are there. आगे आएगा. Certain assumptions करके they told this is what happening inside the container. That's why at constant temperature these all things are happening. बोल के बोला. Understood? चलो.
Sir, 1 minute.
So each and
Yes, sir.
okay. Next. करो question करो. Simple question. P1 is there, volume is there. If the volume को मैं double कर दिया 8 liters, then pressure क्या होगा?
1.
1.
1 rupees. 1 ATM, right?
Hard, yeah.
ATM. So P1 V1 is equal to P2 V2 because isothermal is constant temperature. आपको थर्मोडायनेमिक्स में आने वाला है आइसोथर्मल, आइसोबारिक, आइसोकोरिक, ऐसा एडियाबैटिक बोल के है. ओके चलो आ गया ना राइट टाइम. P1 V1 equal to P2 V2. करो. A gas has volume this much, pressure is much. Volume is telling volume when the pressure is much. Calculate and tell exam answer.
Sir, 400.
देखेंगे.
Sir, 400.
Yes, 400.
400 milliliters. Yes. Next.
Sir, 240.
Yeah, 240.
Yes, 240 kilopascals. Okay, small questions, easy questions. चलो. Now next one is Charles law. Okay. कृष्णा Charles law याद है? Charles law. Anything? Remember? No. Okay. देखो Charles law क्या है देखो. At constant pressure, the volume of a given mass of gas is directly proportional to the absolute temperature. So volume is proportional to temperature at constant pressure. Okay. देखो volume is proportional to temperature at constant pressure. Or when I bring like this, T, V by T is equal to constant. This is a Charles law. V by T is equal. So we can derive from the ideal gas equation, right? PV equal to nRT. At constant pressure bola. So pressure is constant, N is constant, R is constant. That means V is proportional to T. This is only ideal gas equation. So we derived, right? P. So if I know which is constant, then I can tell which is proportional to which one. So from this, V by T is equal to constant. This is only Charles law. Okay. So if you write mathematically,
That's done.
okay. If you write mathematically, V1 by T1 is equal to V2 by T2 for numerical scale at constant pressure. Okay. So now derivation में already PV equal to nRT at constant pressure में both are constant. That's why V is proportional to T आएगा. ये लिखने की जरूरत नहीं है. Now can you explain based on the kinetic theory? Tell me. Based on the kinetic theory, can you tell me V is proportional to T बोल के? At constant pressure. Pressure को take the container में gas molecules are there. Now explain. Molecules are there. Constant pressure constant लगाने का. Then how is proportional to T? Explain करो. Temperature is nothing but average kinetic energy of the molecules. बोलो.
There if temperature is average kinetic energy, if you heat the gas, then the molecules will start vibrating more, so they'll gain more kinetic energy, so the volume will increase.
Increase. Why? To maintain constant pressure. प्रेशर कांस्टेंट के लिए वो पिस्टन विल मूव अपवर्ड्स, वॉल्यूम को इंक्रीज हो जाएगा. ओके, दैट इज व्हाट हैपनिंग. ओके, ग्राफ देखेंगे. ग्राफ का डायरेक्ट रिलेशन आएगा. एंड दिस ग्राफ इज फॉर केल्विन ग्राफ ओनली. व्हेन टेंपरेचर इज केल्विन देन ओनली इट विल स्टार्ट विद ऑरिजिन. अदरवाइज वो ऑरिजिन से स्टार्ट नहीं होगा. सेल्सियस स्केल में, केल्विन स्केल में इट इज पासिंग थ्रू द ऑरिजिन. दिस इज एट 0 केल्विन. 0 केल्विन में वॉल्यूम इज 0. राइट, वॉल्यूम इज 0. ओके, आई विल ट्राई टू फाइंड स्लोप. स्लोप कितना आएगा? टेल मी इसका स्लोप क्या आएगा? स्लोप इज dv by dt, right? Changing y by changing x. Okay, how to find dv by dt? देखो pv is equal to nRT. Here pressure is constant, nr is constant. Okay, I'm partial differentiation we are doing. P dv is equal to nr dt. So from this, what is dv by dt is equal to nr by p. So it is nr by p. This is a slope. Slope of volume versus temperature graph is nothing but nr by p. nr by p. Okay, from this one small conclusion you will get, more the slope, pressure will be less or more? Pressure will be less. More the slope, lesser the pressure. That is important conclusion. They'll give the graph. Exam में क्या देगा? Volume versus temperature graph. Kelvin graph only they'll give. Okay, so they'll give like this. Here x and y. Tell me, किसका pressure more है? Tell me, किसका pressure more है?
X.
Because lesser the slope, more the pressure. So pressure of x is greater than pressure of y. So like these questions they can ask in the exam point of view. Volume versus temperature graph. Okay, now we'll see the graph. Now real gas and ideal gas का graph draw करेंगे, volume versus temperature का. तो आइडियल गैस का तो ऐसा आएगा. रियल गैस कैसा आएगा? इधर स्टार्ट होगा. Here also you can conclude that at higher temperature में the real gas and ideal gas are meeting. It is acting like a real gas will behave like a ideal gas at this high temperature. देखो, real gas will be...
For the graph, will they directly give the graph and ask us to identify, like, can they give a graph with respect to volume, temperature and ask us to find the, like, will there be any graph questions?
Graph questions आएगा. They'll give like small graph, the volume versus temperature graph. That means you have to understand that it is a constant pressure. Charles law का graph है. So in this में only the lesser the slope, more the pressure. देखो slope is inversely proportional to pressure. That one you have to know. Okay. Here in this में, what is the conclusion? That real gas will behave like ideal gas at high temperature. Here also देखो match हो रहा है. Real gas and ideal gas match हो रहा है. So always at high temperature and low pressure में the real gas will always behave like a ideal gas. Now, if the temperature is in degree Celsius में चार्ल्स लॉ बोल सकते हो? मालूम है? डिग्री सेल्सियस में वेरी इंपॉर्टेंट. देखो स्टेटमेंट लिख लो. दिस इज चार्ल्स लॉ इन डिग्री सेल्सियस में. व्हाट इज सेइंग? फॉर ईच डिग्री राइज इन टेम्परेचर, एक डिग्री राइज करूंगा, इंक्रीज करूंगा, लाइक 1 डिग्री टू 2 डिग्री बनाऊंगा. एट दैट टाइम इन सेल्सियस में the volume of a given mass of gas increased. Volume will increase by how much? 1/273 of the volume at 0 degrees Celsius at constant pressure. This is a Charles law when the temperature is at Celsius. Okay, so what is the statement? Volume at T degrees Celsius will be equal to volume at 0 degrees Celsius. This is the original volume is V0 plus कितना increase होगा? 1/273 times that of the volume at 0 degrees Celsius. So I am writing T by or V0 times of V0 times of T by 273. This is a इतना वॉल्यूम इंक्रीज होगा. सपोज मान लो वॉल्यूम एट 1 डिग्री इंक्रीज कर दिया, क्या होगा, कितना इंक्रीज हो जाएगा, 1 डिग्री इंक्रीज किया तो क्या होगा, ओरिजिनल वॉल्यूम प्लस टी के जगह में 1 रहेगा. सो वी नॉट इंटू 1/273 टाइम्स टोटल वॉल्यूम विल इंक्रीज इन डिग्री सेल्सियस में. ओके, अगर 2 डिग्री सेल्सियस बोल तो वी नॉट प्लस वी नॉट इंटू 2/273. दिस इज अ स्टेटमेंट ऑफ चार्ल्स लॉ इन सेल्सियस में, वेरी इंपॉर्टेंट. Now, if I draw the graph of V versus temperature in the Celsius में, V versus temperature in the Celsius में, देखो I'll rearrange V at T degree Celsius is equal to V naught into V naught by 273 T plus V naught. ऐसे ना. Now compare with Y equal to mx plus c. Y equal to mx plus c. देखो y एक्सिस में v है, x एक्सिस में t is temperature, and slope is v naught by 273, and c is intercept, positive intercept है ना, v naught है. So graph is here, positive intercept, that is v naught. ये कितना है, v naught. Since it's a straight line, it will pass like this. Okay, if I go on decreasing the temperature, देखो initially 0 डिग्री सेल्सियस में वॉल्यूम तो रहेगा. If I go on decreasing temperature, क्या होगा, वॉल्यूम डिक्रीज एक जगह में, the volume becomes 0, and that volume is 0, which temperature that is, temperature is -273 degree Celsius or 0 Kelvin. At temperature 0 Kelvin में the volume is 0. So this is Charles law when it is written in Celsius scale, Celsius में. So कितना वॉल्यूम इंक्रीज होगा 1 डिग्री राइज करने से, कितना वॉल्यूम इंक्रीज होगा, ओरिजिनल वॉल्यूम है 0 डिग्री सेल्सियस प्लस द वॉल्यूम इंटू T/273. दिस इज द वॉल्यूम इंक्रीज होगा. समझ आया, चलो कॉपीड. हाँ, काइनेटिक थ्योरी एक्सप्लेनेशन आता है ना आपको, सेम थिंग आई टोल्ड बिफोर. हाँ, नो क्वेश्चन करो.
Sir, once can you go back? Okay, sir.
हाँ, करो. At constant pressure, मतलब चार्ल्स लॉ यूज करें. The volume of a given mass of gas at this much pressure is 100 centimeter cube. What will be its volume at 327 degrees Celsius? And temperature always should be in Kelvin में यूज करना पड़ेगा कभी भी.
Sir, 200.
देखिए.
Yeah, 200.
Yeah.
Yeah, V1 by T1 is equal to V2 by T2. हाँ, ये करो.
Sir, 3.
So 3.
So 3.
Yes, 3 liters.
So 8/3.
देखिए. कितना 8/3 only, Srisha? So yes, 8/3 is 2.61 liters. है ना, केल्विन में कन्वर्ट करने का ऑलवेज. नेक्स्ट. ओके, नो Gay-Lussac's लॉ और प्रेशर लॉ बोलते हैं. Gay-Lussac's लॉ और प्रेशर लॉ. व्हाट इज Gay-Lussac's लॉ और प्रेशर लॉ? एनीबॉडी? देखो, at constant volume, pressure of a given mass of gas is directly proportional to absolute temperature. This is a constant volume. I will tell you shortcut last में कैसे remember करने का. So pressure is proportional to temperature at constant volume. So when I bring P by T is constant. This is a Gay-Lussac's law. लिख लो Gay-Lussac's law. Pressure is proportional to temperature. So you can remember like this. Bluetooth cannot play games virtually. This statement you have to remember. देखो Boyle's law, Bluetooth, right? Boyle's law, constant temperature. Charles' law, constant pressure. Gay-Lussac's law, constant volume. Or remember. From this you can derive from the PV equal nRT में you can tell which formula is useful. Okay. So Boyle's law, temperature constant. Charles' law, pressure constant. And Gay-Lussac's law, volume constant. So Bluetooth can't play games virtually. Because अभी याद रहेगा but after some 6 months के बाद ये याद है तो you can play. Done. Okay, from the mathematically we can write P1 by T1 is equal to P2 by T2. This is a Gay-Lussac's law. Derivation already you know that P from ideal gas equation में P equal to constant volume है ना. So V constant, N constant, R is constant.
So what's the mathematical form? P1 by T1 equals to P2 by T2.
Yes, P1 by T1 equal to P2 by T2. And ideal gas equation se we can get right. We already discussed. Everything is constant. That's therefore P is proportional to T at constant volume. Okay. So this is nothing but Gay-Lussac's law. Chalo. And kinetic theory also you can able to explain, right? Kinetic theory of gas में. Okay. And pressure देखेंगे इसका graph. Pressure and temperature क्या होगा? It is passing through origin. V is constant. So कौन सा ग्राफ है वो देखकर आपको अदर वेरिएबल इज कांस्टेंट इसका ग्राफ मतलब एक Gay-Lussac's law बोल के आपको आइडिया आने का. ओके चलो. किनेटिक थ्योरी ऑफ एक्सपेंशन ऑलरेडी मालूम है आपको, कर सकते हैं ना.
So one second, can I go to the graph once? Oh, yeah, done.
Yeah. चलो करो. At constant volume.
So 3.
3.
चलो नेक्स्ट क्वेश्चन विल डू टिल देखते हैं. फर्स्ट मैथमेटिकली देखते हैं. नहीं दूसरा. ओके दीस आर द लॉस. ओके वी स्टडी दीस आर द 3 लॉस, राइट. कौन सा? बॉयल्स लॉ, चार्ल्स लॉ एंड Gay-Lussac's लॉ, राइट. चलो ऐसा कुछ आता है. ओके आइडियल गैस इक्वेशन के बारे में ऑलरेडी यू नो PV इक्वल nRT. व्हाई वी आर राइटिंग हियर? बिकॉज़ आपको R का वैल्यू इंपॉर्टेंट है. R इज यूनिवर्सल गैस कांस्टेंट. R का वैल्यू कितना है? I want
2 calories per gram. It's 8.314.
8.314.
ओके दूसरा R वैल्यूज
0.8314.
0.021.
2 calories.
वेरी गुड सुपर. सो PV इक्वल nRT में this R वैल्यू इज इंपॉर्टेंट. R का 8.314 joules per mole Kelvin और 0.0821 liters ATM mole inverse Kelvin inverse and R value 2 calories mole inverse Kelvin inverse. करस्पॉन्डिंग में आपको यूज करना पड़ेगा. केल्विन में दिया टेम्परेचर, मोल्स में दिया मोल तो जोल्स में यूज करो. . Okay, done. चलो, तो आइडियल गैस इक्वेशन देखो, यूजिंग गैस लॉस का दिस ऑल आइडियल गैस इक्वेशन कैसे डेराइव किया, ऑल गैस लॉस मिलके विल गेट द पीवीटी इनर्टी, राइट? देखो बॉयल्स लॉ, चार्ल्स लॉ, इसका गेलो-सैक्स लॉ, तीनों मिलके विल गेट दिस वन पीवी इक्वल इनर्टी. दिस वन ऑलरेडी यू नो, केमिस्ट्री पढ़ा है ना. हाँ, आइडियल गैस एंड रियल गैस का इसका क्या अंतर है, वी विल सी इन दिस ग्राफ्स में. एंड हियर ओनली विल गेट दैट लो प्रेशर बोल के आपको आएगा. देखो, वी नो दैट पीवी इक्वल एनआरटी इज आइडियल गैस इक्वेशन for 1 mole of gas. So PV is equal to RT. I can write PV by RT is equal to 1, right? PV by RT is equal to 1. Now I will draw the graph for the PV by RT graph only I will draw. PV by RT versus pressure graph. And ये आइडियल गैस इक्वेशन है ना, पीवी बाय आरटी वैल्यू इज सो मच 1. सो आइडियल गैस का कैसा रहेगा, 1 नहीं आएगा, ऐसा इज आइडियल गैस का. बट इफ यू टेक ए रियल गैस एंड यू विल कैलकुलेट exactly PV by RT for the real gas, I got the temperature like this. Real gas का ऐसा आएगा, T1 temperature. If I increase the temperature, then they observe the graph is like this, T2. Matlab what is happening here? Here also you can see as the temperature increases, T2 is greater than T1. As the temperature increases, the real gas is behaving like an ideal gas. It's coming closer to the ideal gas, right? And दूसरा, at low pressure, देखो low pressure में real gas is behaving like the ideal gas. Okay, that's why in starting से मैं बोल रहा हूँ real gas will behave like ideal gas at high temperature and low pressure. Okay. So at high temperature and low pressure, the real gas behaves like an ideal gas. So मैं
Yeah.
3 laws आपको मालूम हो गया अभी. Bluetooth can't play games virtually. Done? चलो. Now suppose मान लो all 3 are changing, pressure, volume, temperature. आपको आइडियल गैस इक्वेशन यूज करके P1 V1 by T1 is equal to P2 V2 by T2 यूज करना पड़ेगा. दिस इज द कंबाइंड गैस लॉस. आपको आइडियल गैस यूज करके आपको तीनों अगर चेंज हो तो P1 V1 by T1 equal to P2 V2 by T2 that use. They'll tell to find V2 कुछ T2 ऐसा बोले तो you have to use this equation. अपना
Yes, sir.
चलो इसका आंसर दे दिया. देखो प्रेशर इज 2 atm 3 atm T1, मतलब यूज दिस वन P1 V1 by T1 equal to P2 V2 by T2. सिंपल. फाइंड V2 फाइंड करो कितना आएगा. When 3 are changing directly you can use this one.
So 8/3.
Yeah, 8/3 is answer. So now next one is Dalton's law of partial pressure. Dalton's law of partial pressure is easy only. What is saying, suppose मान लो एक कंटेनर है, फिक्स्ड वॉल्यूम है, टेम्परेचर फिक्स्ड है, इधर एक गैस नहीं रखा, I put 3 or more gases I put, which is non-reacting gases I put. Then what will happen? आपको total pressure in the container चाहिए. Then how do you calculate total pressure in the container? एक एक गैस का कितना exert कर रहे pressure, you will calculate and add up. That is only Dalton's law. To get the total pressure, sum of the individual pressures use the total pressure in the container. This is only Dalton's law. देखो P is equal to P1 plus P2 plus P3. This is only gas law. Dalton's law of partial pressure means total pressure is always equal to sum of the individual pressures. And pressure का formula क्या है? N1 RT by V, because PV equal to nRT, right? PV equal to nRT. So from this P is equal to nRT by V. देखो volume is constant, temperature is constant of all gases का. That's why number of moles only will change, right? So N1 RT by V, N2 RT by V, N3 RT by V. This is nothing but P1 plus P2 plus P3. So this is the Dalton's law of partial pressure. इसमें क्वेश्चंस आर देयर, आप जो भी है पूरा आपको पीवाईक्यूज करने समय सब कुछ आएगा आपको. What is
I'm not
Dalton?
writing the statement on the statement.
Statement, no need. You can write P equal P1 plus P2 plus P3. Non-reacting gases का always pressure will be total sum of the individual pressures का add किया तो will get total pressure. Done ना? चलो हाँ करो. A vessel of volume contains 0.1 mole of oxygen and 0.2 moles of carbon dioxide. Though gases are there in a container. If the temperature of the mixture is 300 Kelvin, temperature also fixed here, volume also fixed here. Find the pressure. Total pressure in the container. You already know total pressure is always sum of the individual pressures. Use करो. दो गैस है ना, दो गैस का इंडिविजुअल प्रेशर करने का. So N1 RT by V plus N2 R2 RT by V.
So in what unit should we tell the answer?
Yeah, लेकिन प्रेशर ऑन राइट, प्रेशर का क्या दिया वही है टीम. R you can take 8.3.
So can I use calculator?
हाँ यूज करो. चलो
0.3 into 8.
So should we use 8.3 or 0.08?
no 8.3 यूज करो. एंड सेंटीमीटर क्यूब को जब मीटर क्यूब का कन्वर्ट कर रहा है.
373.3 once again. 373.5 kilopascals.
So I got 3.735 kilopascal.
ओके तो 3 पॉइंट चेंज आ रहा है ना. यस 3.75. गुड. Anshuda, Kala?
Sir,
Tell me.
sir, shouldn't it?
देखो N1 I am taking common, RT by V common. So and V मालूम है ना V का.
Sir, when you do that, you'll get 375,000 pascals.
ATM में we are telling
Yeah.
answer, right? Yeah. Hi,
So
Krishna.
now I'm getting 373500.
Yeah, no problem. ATM में आएगा उसमें उसमें क्या आएगा आपको किलो पास्कल्स बोल रहे हैं ना उसमें कन्वर्ट किया. ओके ओके नेक्स्ट ये करो जेईई मेंस क्वेश्चन.
So 24.9 into 10 to the power 5.
ऑप्शन नंबर
So C.
देखेंगे.
Sir, I got C.
C.
Yes, good. Okay. The last law is Avogadro law. Avogadro law क्या है? That it says that for a fixed temperature and pressure, देखो दोनों different gas are there, oxygen, nitrogen is there. I am keeping temperature fixed and pressure fixed. Okay, temperature and pressure is fixed. So in that condition में equal volumes of different gases, if I put the volumes equally, then the number of molecules will be same. मतलब अगर ऑक्सीजन एंड नाइट्रोजन में इक्वल वॉल्यूम्स में लगाए तो they told that according to this law number of molecules also will be same. Suppose this x molecules है तो इसमें भी x molecules है. Constant temperature and pressures. So equal volume gas लिया मैं, equal volume gas लिया, that means indirectly the molecules also will be equal. That is only Avogadro law. Okay. और दूसरा मेथड क्या है? दूसरा क्या है? At constant temperature and pressure, the volume of a gas is directly proportional to the number of moles of the gas. That means indirectly volume is proportional to number of moles. So V1 by N1 is equal to V2 by N2. For numericals, this will help. So more the number of moles means more the volume will be there. When a temperature and pressure should be constant. That is the thing important. So V1 by N1 is equal to V2 by N2. We can directly use when constant temperature and pressure.
So one second.
Later.
So one second. Yeah, so done.
Okay. चलो. ठीक है. 2 moles of a gas occupy 10 liters. What volume of with 5 moles occupy at same temperature and pressure? At same temperature and pressure, 5 moles will occupy how much volume? So moles में दिया ना एक constant temperature and pressure. So V1 by N1 is equal to V2 by N2 you can use.
So 25.
देखें.
Yeah, 25.
Yeah, 25 answer. 4 moles of a gas occupy this much. How many moles will occupy 5 liters?
So 1.
Yes, 1 mole is answer. Yeah.
Yes.
2 moles of gas occupy this much liters. What volume is much? Same temperature pressure, same model. करो.
So 3.75.
So 3.75.
Yes, 3% is answer. Okay, now we'll talk about the density of gas. Losses are done. All gas loss done. Okay, so gas loss क्या क्या है? Boyle's law, Charles law. Statement पूरा याद है? Boyle's law, Charles law, Avogadro's law, and इसका Dalton's laws of pressure. So मेरा okay. Now density of a gas के बारे में learn करेंगे. Okay, density of the gas also we can get from the ideal gas equation का. What is the formula ideal gas equation में? PV is equal to nRT. Density is nothing but mass by volume, right? वो use करने वाला है. Okay, PV is equal to what is mole? Mole में definition given mass by molar mass, right? Given mass by molar mass into RT. Okay, मैं V को नीचे फेंकूंगा. So P और M by V को. From this, what is M by V from this? Tell me. What is M by V from this? M by V is equal to Pm by RT. So this mass by volume is nothing but density. So density is equal to Pm by RT. This is a formula for density of the gas. Pressure, molar mass, or T should be Kelvin. In terms of Boltzmann constant, can you bring Boltzmann
PV
constant?
is equals to NKT.
Hmm?
PV is equals to NKT.
Okay, but from the density I want.
Oh, I forgot.
देखो, density is equal to okay, molar mass is nothing but mass of one. See, whenever Boltzmann constant comes, molecules में आएगा. Mass of one molecule के बारे में आएगा. So mass of molecule into Avogadro number is nothing but capital M by R into T. And Na को नीचे फेंकूंगा. Density is equal to P, right? P into M into Na by RT, right? So P M by R by Na into T. So what is R by Na? Is nothing but Boltzmann constant. So P M small m. Small m is mass of one molecule of a gas by Kb into T. This is a formula for density in terms of Boltzmann constant. Whenever Boltzmann constant comes, small m आएगा, mass of one molecule. Molecule terms में Boltzmann आएगा. They will all mention exam में, questions में mass of the molecule of this gas is this much बोल के, तो we have to use Kb का. Okay, so density का formula क्या होगा? Pm by Kb into T. the formula. Boltzmann, and this is small m is mass of one molecule. Mass of one molecule. So formulas आपको बाहर करना पड़ेगा. Okay, now we'll ask one question. Try करो. And Boltzmann constant का value कितना है? KB value is how much?
1.35 into 10 power minus 23.
1.38. 38
Oh.
into 10 power of minus 23 joules per Kelvin. This is a value at by at KB. 1.8 into 10 power minus 23. Okay. And now exam they'll ask what is the dimensions of KB. बोल्ट्जमैन कांस्टेंट का डायमेंशंस कैसा रहेगा?
So now what do I have to find?
Dimensions of KB. ML वाला याद है? MLT वाला.
So that's K minus 1.
Okay.
Wait. T is in the denominator. So T will also be minus 1. So it'll be M1 for sure.
अरे पूरा बोलो पूरा.
Wait.
So M1, L2, T power minus 1, temperature power minus 1.
देखेंगे.
So I got M1, L2, T power minus 2, K power minus 1.
M1, L2.
M1, L2, T power minus 2. I mean T power minus 1, sorry. And K power minus 2. No, reverse. My bad. T power minus 2, K power minus 1.
Okay, ये आया आपको भी? प्रणव? क्या आया?
Yes, sir.
कुछ
It's the same thing.
Same thing. Good. Generally, KB into T is nothing but देखो आपको units के देख सकते ना. KB into T is nothing but किसका energy का dimensions. Because joules है ना. KB into T is nothing but energy का dimensions. वो याद रखो always. Okay. So इसके बाद we have to see the postulates of the kinetic theory and different speeds, RMS speed, average speed, most probable speed and mean free path. Next class में हो जाएगा chapter done.